This is the first camera stand that I've made, and I'd like to create a miniature version of it as well as implement some design improvements to make the second iteration a little bit more practical. The top piece has this oblong pin that's here to hold my phone. It also has two separate articulations, one that allows it to pan and the other to tilt. I'd like to replace this assembly with a ball and socket joint because, as it's currently made, if I pan the camera and tilt it at the same time, the phone goes out of level with the ground. The legs are connected to one another via these brackets, which meet at this triangle piece in the middle. I didn't even stutter that time. Mom is home. This center assembly is here to ensure that the legs are coming off the mounting platform all at the same angle, which in turn ensures that the platform is level to the ground. I should also mention, I got this ball from an arts and crafts store, since I don't have a lathe so I couldn't make it myself. And here you can see me meticulously gluing the trim pieces to the wrong side of the socket joint. It's the wrong side because the other side has this groove cut into the circle that I didn't film, and I didn't film that because I did it out of order and really should have been cutting both the top piece and the trim pieces in one pass right here. The ball and socket assembly have a hinge and then a screw that goes through the other side to tighten around the ball and lock it in place. I drilled out the majority of the material with the drill press and then used the hammer and chisel to make that hole hexagonal instead of circular. So I split the bottom piece here when I went to drive the nut, and the reason this bottom piece is here is twofold. One, because the ball protrudes slightly from this face so that I can't glue something on the bottom of it without hitting it, and the second is because there was already a crack on the top piece, but now with both of these cracks, when the nut gets pressed in, it bends the entire bottom piece. So I'm going to try to remake it and then... So I've gone ahead and remade the bottom piece, and I made it a bit thicker so that that ball doesn't protrude from the face. We have the nut inset here, and the way this works is that the ball goes in like this. This screw goes through this block and engages the nut on the back. And then the holder has a block on the back that has a hole drilled through it, which fits onto this dowel. And then I can adjust it as necessary. And you'll notice there's a slight gap here between the bottom piece and the actual body of the holder. And when I tighten this screw, that slop goes away and it secures the phone in place. And now on to making the base to which the legs are going to be attached and hinged from. Since they're going to be spaced 120 degrees apart, I went ahead and made that base a circle, and you can see me approximating that circle here on the bandsaw. After putting in a single screw for each one of those hinge blocks, I went ahead and screwed the entire thing to the bottom of the ball and socket joint. And now onto cutting the blanks from which the legs are going to be made. Off camera, I also put a piece of white oak at the end of the legs so that the part that contacts the nail is made out of a harder wood and more resistant to wear. So I want the legs to be joined together the same way they are with the original. This involves a bit of trigonometry, and I thought this trigonometry would warrant an explanation just to demystify how some of this works. Here we have a cross-section of one of the legs, and I want to calculate the length of this horizontal line so that I know how to size those brackets I mentioned earlier. Now, if this were a triangle that had one 90-degree angle and two 45s, I could just calculate it manually, that is, without using trigonometry. If this side is 1, then this has to be 1 times the square root of 2. Unfortunately, not all triangles have such convenient properties. Now, trigonometry is really just a way of communicating with the calculator. The calculator has a list in its memory. It's a list of every combination of right triangle you could draw. Corresponding to each respective triangle is the relationships of the different sides and angles of the triangle, exactly like how we had for this one. Trigonometry is simply a way of telling the calculator, given this information I have about the triangle, tell me what the rest of its sides and angles are. Here I want the angle of the leg with respect to the mounting platform to be equal to 25 degrees. I also know that the hypotenuse of this triangle equates to how far down our leg I place this pin. So how do we tell the calculator what we know? Well, in school you probably learned this mnemonic device, SOHCAHTOA. TOA. Here, sine equates the opposite, which we don't know, and the hypotenuse, which we do know, to our original angle. Hence why it's SO, OH standing for opposite and hypotenuse. So the equation would go something like this. Sine of 25 degrees equals opposite over 9. Put into words, this equation is asking the calculator, given an angle of 25 degrees in a right triangle, what is the ratio of the opposite side over a hypotenuse of length 9? The calculator looks down its list and finds that for an angle of 25 degrees in a right triangle, the ratio of the opposite side over hypotenuse is 0.42261 over 1. Now here we have a hypotenuse of length 9, not 1, so if we multiply both of those by 9, we get a ratio of 5.785 over 9, which means that the opposite is simply 5.785 centimeters. The bracket needs to be sized slightly bigger than that because we want to put a hole here. We don't want the wood to actually terminate here. I've gone ahead and affixed these brackets in place just using some tape, and you can see that those brackets sort of trace the silhouette of a triangle right in the center. If we look at an overhead view of the center assembly on the bigger one, you can see that this triangle is traced out by these brackets. So taping these together gives me an idea of how big I need that triangle to be. After cutting those pins off to size, I added a big glob of solder to the end to prevent the brackets from slipping up. So at this point in the project, I still had to come up with a way to get these legs to lock after they're telescoped to the correct height. And the first design I went with was to drill a bunch of holes in the part that moves, put a corresponding hole through here on the part that doesn't, and then have a pin that goes through both holes to lock it in place. And that worked fine, but it wasn't very convenient in the way of adjustability. So the second design I came up with was to have a bunch of screws countersunk and studded along the length of the piece, and then a magnet embedded in the part that doesn't move that would attract the head of the screw as it went by and lock it in place. And that was great in the way of adjustability, but it was very weak because the magnet wasn't very strong. So if I put it down on the table with any amount of force, the legs just fold in and it doesn't work the same way. I ended up breaking this piece in frustration. But the third design I came up with was the same, was kind of an amalgamation of the two, and I came by it almost by accident. I have this screw that's going through a dowel here, and then two ring magnets that go at the end, which the screw protrudes through. And then if I take this entire assembly and I put it in a hole that I've drilled here at the bottom of the piece, you can see that the magnet ends up bottoming out at the bottom of the dovetail because of those two sides that hold it in place or prevent it from going further. So if I put this in here, you'll notice that we have the magnet and then that pin sticking out slightly. And this corresponding mating piece has a bit of play. So the way this works is you can telescope it by pushing it out and bypass the pin, but then once you find the correct setting, you push it in, and then the pin catches on the head of the screw and prevents it from going further. And that magnet is there so that this piece doesn't get pulled out by itself and loosens the entire leg. And this works pretty well. So I gave this a coat of polyurethane to give it some protection and also to make it prettier. Though with the crappy plywood I used, I didn't really make much headway in that respect, but I'm happy with the way it turned out. Each separate mechanism, the legs, the middle assembly, the ball and socket joint, and this disc with the holders on it, and the holder. I made each of those at least twice, or in the case of the legs, 3 times. So it does take a lot of trial and error. Doesn't go together seamlessly, but it's worth a shot if you guys want to replicate it. As for why I didn't show the holder, I don't anticipate many of you are cheap enough to use a phone for this sort of thing.
I'm not sure what to do with my hands.
It'd be good just to hold them down by your side.
I just don't have access to a camera, so until the channel gets more traction, that's what I'll be using. But thank you guys for watching. Stay safe, don't die, and I'll see you guys in the next one.